Let's discuss question number 8 from test 2. This is from bending movements of SOM. So a beam is given. Basically you have hinged at A and you have roller at C and B is somewhere in between. You have an extension to the beam and where a 3 kilonewton is applied. So all these points are 1 meter, 1 meter and 1 meter. Wait. Okay, so we are asked to find out the bending moment at B. Now first let me just tell you something which is important. So a load at this at 3 kilonewton, you have the load. So a load can be replaced by the same load and the couple at other point, the effect being the same. So this is 3 kilonewton and this is so at this point I can replace this 3 kilonewton as 3 kilonewton into the moment, which is 3 into the length of this is 1 meter, so 3 into 1, so 3 kilonewton meter I can replace. So this is point A. You have the hinge, so let's write AY, and CY you have the reaction CY. So this is basically a single beam where you have this is the equivalent loading. Now I need to get the reaction CY. So for this what I can do is basic static equilibrium. As the beam is in static equilibrium, I can say moment about A is 0 because AY is something I may not require. So moment about A is 0 and also the summation of force, vertical forces is 0. The summation of vertical force is AY plus CY is upward forces. Downward force don't have any downward force, so that's the thing. And the horizontal force AX is there, so that AX plus your 3 has to be 0, so X will be minus. Now, sigma moment about A. So these are your 3 equilibrium equations, static equilibrium equations. Moment of A. Now about A, if I want to find moment, AH doesn't produce any movement because it's passing through A. AY doesn't produce any movement because it's passing through A. 3 kilonewton doesn't produce any movement because it's passing through A. Coupled M will appear as M only clockwise. CY will produce anti-clockwise, so minus CY into total length, which is 3, equal to 0. So this will give CY is M by 3. M is 3 by 3, which is 1 kilonewton. So CY is 1 kilonewton. And therefore AY will be minus CY, which is minus 1 kilonewton from this equation. Okay, so now we want to find bending moment at B. So why not if I consider only the right hand side part? So let's take a section at B and consider only the right part of the beam where I know the reaction now, which is 1 kilonewton, and at B I need to find the bending moment. So at B, because it's a cross section, the internal forces I can just represent the shear force V and the bending moment M in this way. I need to find bending moment at B. So what I can do is the net moment about B has to be 0. So MB is clockwise. This one at CY is 1 into, which is 1 meter, is 1, anti-clockwise 0. So there are no other moments. So the bending moment at B would be 1 kilonewton meter. So the option is 1 kilonewton meter. So answer is C. So basically it's all about getting the reactions first and then taking a section and considering either left part or the right part of the beam where so take a section where you need to find out bending moment and then consider left or right. We have considered right because you have only right of B is very simple, you have only one loading CY. So that's the thing. So option is C. Thank you.